Hi Chemistry, this is your video for how to solve Hess's Law problems of enthalpy. This is a really tricky thing for me to try to teach you guys via video. So I'm going to do my best, but you are going to have to excuse my poor videoing skills because I'm doing this all by myself and we're going to be using a whiteboard as we do it. So I'm going to turn around the view of this camera. The first thing you guys need is your Hess's Law Practice problems. These are available in Canvas. They are in your thermochemistry module. So I'm going to do two problems with you today. The two problems I'm going to do are number 1 and number 7. So what I would like for you to do is I want you to download this document. After you have downloaded it, you have to go to File, then make a copy. Okay, File, make a copy so that you can type on your copy of this document. These problems are really best for you to do with the use of a whiteboard. Here is my whiteboard. It's in my lap. I'm going to be writing some things on it as we go, as we work through these problems. Okay? Now, all of your homework part can be done on your whiteboard. And then what you will record will be the official enthalpy. And enthalpy is abbreviated as a capital H. You can copy and paste this little delta H right here if you want. But sometimes your computers are weird about it, like mine is being weird. So I am going to let you just abbreviate it as a giant H for enthalpy equals. You're going to put your final amount right up there. So I gave you a lesson yesterday on how you're going to solve Hess's Law problems. So we said the 3 things that we're going to do to solve a Hess's Law problem are, number 1, you're going to look at the summative equation. This is my summative equation that's highlighted in blue, the B2H6 plus 6Cl2. And then we're going to rearrange the base equations that we have below in order to find the things that we need, such as B2H6, and we got to get them on the proper side of the arrow, reactant side versus product side. So the first thing I'm going to do is I'm going to say I need to find B2H6. And it needs to be on the reactant side of the arrow. So I'm going to scan my 3 equations provided. Right there is my B2H6. It's in equation 2. So I'm going to say to myself, is it on the proper side of the arrow? Is it a reactant? And yes, it is. So once I know that it is a reactant that is in the proper side, what I'm going to do is I'm going to write down equation number 2. I can write it on my whiteboard. And I'm also saying to myself, do I have enough of the B2H6? I need one of them, but I have one of them. So equation 2 must be fine the way it is. As I write it on my whiteboard, you are welcome to leave out the little G for gas, L for liquid. That's just extra info. You don't really have to write it out. Okay? It gives me 2 H3BO3s plus 6 H2s. As I write this out, I'm going to write down my enthalpy. I always have to note if there's any changes to the enthalpy value. That's my delta H in kilojoules, found right there. Because I didn't do anything to equation 2, I keep my enthalpy value as is. So what I did on my whiteboard, if you can see my whiteboard, is there. I wrote it out in my equation 2 spot. I left it as is, and I recorded my enthalpy value. So the next thing that I am going to do is I'm going to look for 6 Cl2s in my base equations down here. There's my Cl2s. They're in equation 3. I don't have 6 of them, though. I have a half of a 1. That's really weird that they do that to you. They're just kind of mean in Hess's Law problems. So what can I multiply this entire equation by so that I can get 6 chlorines instead of a half? I hope you're saying to yourself 12. So what we're going to do is we are going to multiply this equation by 12. When we do that, we type it into the heat value. I need to make the change to the heat value. I'm going to highlight it so that we remember what we did. So then, as I record this equation right here on my whiteboard, I'm going to multiply everything by 12 as I go, as I'm recording it. So instead of having a 1/2 of a hydrogen, I'm going to get 6 H2s plus 6 Cl2s. That gives me 12 of the HCl's. And on my whiteboard, I'm just going to do the changes to my enthalpy value. I'm multiplying my heat value by 12 as well. So as you can see right here, this was what I did. I recorded equation 3 down because I know that it's good the way it is. All right. Now, the next thing I'm going to do is I'm going to look for 2 of these BCl3s. Well, I bet they're not in equations 2 and 3 because I kind of already wrote those down. So, look, equation 1 has BCl3. It's not in the right place. I want it to be on the product side. So you know what I got to do? I got to give this one the flip. So I'm going to write down first that I am flipping it. When I flip something, I must change the heat value from negative to positive. So I'm going to make my change here. I'm going to highlight it for you all so that you remember what I did. Okay, I flipped it. And the other thing was I need 2 of these. So I forgot to talk about that as I'm typing and talking. I'm going to also multiply it by 2 because I'm going to need 2 of them. All right, because I need 2 BCl3s. And I'm going to now rearrange these. You don't have to rearrange these on your homework sheet if you don't want to. That's a lot of copying and pasting and getting fancy on the computer. So I suggest you just do them on the whiteboard, kind of like I am. I hope you have a whiteboard. If you don't have a whiteboard, then I hope you're going to do them on a piece of paper. But I'm going to multiply each of these by 2 as I do it. So I'm going to do 2 BCl3s get written on the product side, plus I had 3 waters. Look, right there I have 3 waters, but I'm going to multiply it by 2. That's going to turn into 6 H2Os. I am writing those on the product side, and then I'm going to write the stuff on the product side over here on the reactant side. So I'm going to write 2 H3BO3s plus 6 HCl's. Okay, so I changed my heat value. I now have a positive 112.5 and I multiplied it by 2. So I'm going to show you what my whiteboard looks like and all of this beautifulness. I have now rearranged the equations as needed. My next thing to do is I'm going to grab a different color marker real quick. Bear with me. I had to stand up, sorry. So what I'm going to do is I'm going to underline the things that I needed. Sorry, I'm a terrible videographer, but I needed some B2H6s and I needed some BCl3s and I need some HCl's and I needed some Cl2s. I kind of underlined in purple all of the things that I needed in a very specific place. Okay, those were the things I needed. My B2H6s, my Cl2s, my BCl3s, and my HCl's. So our next thing to do is to cross out or delete things that are found on opposite sides of the arrows, but don't make their way to the final equation. So an example would be, see these H3BO3s? I got 2 of them here. And look, I have 2 of them there. I don't need those. They cancel each other out because they're on opposite sides of the main yield arrow. So just like adding equation systems in math, they will go away. Do you see these 6 HCl's? I have 6 of them here. Look down here, I have 12 of them. Well, I can get rid of all 6 here, but I can only get rid of 6 of my 12 on this side. So 12 minus 6 becomes a 6. When I look at my H2O, I didn't underline it because you know why? Look, I have 6 of them here and I have 6 of them there. They're going away. I'm just going to strike through them so that you guys don't forget what you had there. Like normally when you get good at these, I'll just erase them entirely. But here I have 6 H2s, and look, there I have 6 H2s. They're on opposite sides of the arrows, so those 2 things go away as well. So in the end, what I end up having is exactly what I needed. I needed a B2H6. I needed plus 6 Cl2s. Yield arrow gives me 6 HCl plus 2 BCl3s. Okay? We're going to always check our work and make sure that we end up with exactly what they asked us to find up in that blue equation. And it is. It's exactly what I needed to find. So now, all that I have to do is, where's my mouse? I'm going to now do the sum total of all these heats. I'm going to take a positive 112.5 and multiply it by 2. Then I'm going to add to it a negative 493.4. Then I'm going to add to it a negative 92.3 times 12. Please put parentheses around these as you do it in your calculator. That's not supposed to be a 9. I was supposed to hit parenthesis. Boom, put a parenthesis. When you get this whole thing done, you should get a negative 1376. That's your final answer for number 1. Okay? We're going to scroll down here to number 7. I'm going to do number 7 with you. Hopefully then you'll be thinking, oh, that's not too super bad. Okay? So what I'm going to do for number 7 is, first of all, sorry, I'm grabbing an eraser. Here we go. I erased my whiteboard. It's clean and beautiful again, so I can write number 7 with you guys. Number 7. First thing we need to find is 2 nitrogens. We're looking down here for nitrogens. Oh, there's some nitrogen. It's in equation 3. I don't have as many of them as I needed. I only have 1 of them. So that lets me know I better multiply equation 3 by 2 because I need 2 nitrogens and that's the only place I can get it. So what I'm going to do is I'm going to come up here and I'm going to make note that I am going to multiply my heat value by 2. Okay? I always like to make note of this before I record my changes because I feel like if you don't, you will forget all about it. All right, now, as I write it on my whiteboard, I'm going to write 2 N2s plus 6 O2s because I'm multiplying each coefficient by 2 plus 2 H2s, yield arrow, gives me 4 HNO3s. I'm going to save myself some room on my whiteboard and not write my enthalpy down on my whiteboard. As you can see, like I did here, that's what I did on my whiteboard. I wrote equation number 3, but multiplied each and every coefficient by 2 because that's what I'm going to need to do. The next thing I'm looking for is 5 oxygens. Well, look at this. I have 6 oxygens in equation 3. I'm just going to kind of leave my oxygens alone for right now because I have some right there. So the next thing I want to look for is 2 of these N2O5s. Oh, look, equation 2 has the N2O5s. they're not on the right side of the arrow. So that means I have to come up here and I have to write that I am going to flip equation 2. When I flip it, that means I didn't mean to delete my 7, but this was a negative, so I'm going to turn it to a positive 73.7. As I'm flipping it, I'm going to say, do I have enough of them? I need 2 of them, and I only had 1, so I'm going to flip it and times it by 2 because I'm so good at this, and I like to do as much as I can all at once, okay, so I don't have to write it multiple times. So I'm going to write these reactants over on the product side, okay, and I'm multiplying everything by 2. So I'm on the product side, I'm going to get 2 N2O5s plus 2 H2Os. On the reactant side, I'm going to multiply this. I'm going to move the products to the reactant side. So I'm going to get 4 HNO3s. So here is what I did for equation 2. Okay, I flipped them and I multiplied them by 2. Now all I have to do is figure out, does equation 1 get to stay where it's at? Or do I need to do something else to it? Well, it really lies in this 5 oxygens. So let's look at equation 1. I got hydrogens, oxygens, and waters. If I leave this oxygen where it's at, it will add to what has become my 6 oxygens on the bottom. So 6 plus 1 would give me 7 oxygens. I want to have 5 of them because, like I said, on the bottom, look, I've got 6 of them on the bottom. So I'm going to flip equation 1 because I need one of these to cancel out. So what I'm going to do is I'm going to say flip equation 1, which means change your heat value from a negative to a positive. We're going to highlight it to show that's what we did to each of these. We're going to flip it on the whiteboard. So my 2 H2Os become reactants, and then my reactants, my 2 H2s plus my O2s, become products. Okay, I'm going to stick it up there so we can see what we needed. We're going to underline the things we needed. We needed N2s. We needed 2 N2s. We needed 2 of these N2O5s. We needed some oxygens. And I think that's all we needed. Let's look. Those were the 3 things we needed. Yeah. So we're going to look at other things to cancel out now. Okay, let's cancel some things out. Anything that's not underlined should most likely cancel out. Here are 4 HNO3s, right? Cross them out of there. There's the other 4 HNO3s. Cross them out of there. Okay, here are 2 H2s. And up there on the opposite side of the arrow are 2 H2s. They don't need to be in the same equation. They just need to be on opposite sides of the main yield arrow. Here are 2 waters, and there are 2 waters. Cancel them out. And then lastly, see this 1 oxygen? I'm going to get rid of 1 oxygen on this side. And that means I can get rid of 1 of my 6 here. So 6 minus 1 is 5. Guess what? I just ended up with exactly what I needed. 2 N2s plus 5 O2s produces 2 N2O5s. So everything that I did right here on my heat values, I'm going to do the sum total of now. So in your calculator, tally up the overall enthalpy value. You will take a positive 571.6. You're going to add to it the total of 737 times 2. And then you're going to add to it a negative 348.2 times 2. And your overall enthalpy value, which we'll just abbreviate as capital H, should equal 22.6. if you didn't get that, you might have pushed your buttons slightly wrong. You might need to simplify any of these multiplications first. Okay, but it's a positive 571.6 plus, put a parenthesis around 73.7 times 2 end parenthesis, plus use a parenthesis, negative 348.2 times 2 end parenthesis equals, you should get a 22.6. Okay, so I did 2 out of the 8 for you. I hope that that makes sense. I hope that you have a whiteboard at home that you can use to do this with, or some dry erase markers and your periodic table with just one of those sheet protectors on there. Works really well so that you can rearrange things and erase things. Try the next 6. Once you get them all solved and you have recorded your standard enthalpy value, just as I have recorded my standard enthalpy value right here, okay, next to each equation in blue, then what you can do is you can upload it to Canvas for me, okay? Good luck. They're a little bit tricky. They're kind of like brain teasers. They get easier as you go. If you're feeling really stuck on them, please feel free to come in after school any day of the week next week, and we can work through some of these together, okay? It's a really difficult thing to try to teach via this iPad, but I think hopefully you can understand what I was doing, and good luck. I will see you all soon. Bye.